Yes, students, it is a time to know the importance of Heisenberg's uncertainty principle. He was saying there is a certainty of uncertainty. Because of that, now a modern model for atom we consider as electron cloud model. Previously, what were we saying? Yes, nucleus possesses protons and neutrons, which is at center, and electrons are revolving. Now, revolution term washed out. Because of uncertainty, electron is there anywhere nearby its jurisdiction in its various orbitals, and orbitals have their shapes. How their shapes can be defined, that we are going to discuss later on. Today we are going to answer for important question: why are electrons outside? Why not electrons in the nucleus? Possibility is there, no? Electrons in the nucleus and protons outside, but it is not going to happen. Reason we will find with the help of Heisenberg's uncertainty principle. By the way, positions of protons and neutrons that we say at nucleus, why for? So exact scientific reasons for location or positions for our nucleons we are going to study. One by one, let us see where can electron exist. Afterwards, about proton. Then we'll discuss neutrons.
Since we never know exactly simultaneously position and momentum for the electron, means uncertainty is there in their measurement, in their finding. It is not because of the instrumental error, it's a reality, and that we need to accept. Then, in order to explain the finding of electron, we express its density term. We express probability of finding the electron. Only if we see the wave function, which is represented as psi, it has no physical significance other than simply existence, means other than its amplitude. But square of that wave function gives us idea about probability of finding the electron. So we are interested now in the psi square. So with the help of the psi square, we can get the idea about where electrons do exist. It is found that electrons are not existing at a nucleus. They are around. But only we have not to accept it blindly. We have to prove it. At the center of the atom, there is nucleus. So two options are there. Electron can be inside, means within nucleus, or can be outside. We will prove electrons cannot exist in the nucleus. So nucleus size is very small. It is about 10 raised to minus 15 to 10 raised to minus 14 meter. Out of that, let me consider maximum size 10 raised to minus 14 meter. So now puzzle in front of us. If we consider error in the measurement of position, and if that error maximum is 10 raised to minus 14, means delta x is equal to 10 raised to minus 14. What is a value for uncertainty in momentum? That we will find out. And from uncertainty in momentum, we can find out uncertainty in velocity. Let us proceed one by one. Now listen carefully. My statement is, if electron has to exist, or anything which has to exist in the nucleus, then uncertainty in its finding the position will be 10 raised to minus 14 meter. Means delta x is equal to 10 raised to minus 14 meter. From that, I will find uncertainty in momentum, delta p. That will be minimum uncertainty, because what is our rule? Delta x into delta p greater than or equal to h upon 4 pi. Now I am considering minimum uncertainty. So minimum it equal to h upon 4 pi. From that expression, you will easily understand the new expression that I am representing here. Delta P minimum is equal to h upon 4 pi into delta x maximum. Maximum uncertainty in position is size of the nucleus. And what is the size of the nucleus? Maximum size 10 raised to minus 14 meter. Let us substitute our values. Planck's constant 6.626 into 10 raised to minus 34 joules second. The 4 as it is we will consider. The value of pi, let us consider up to 2 digits after decimal point, means 3.14. And what is the value of delta x maximum? 10 raised to minus 14 meter. With unit I am representing there. It's always better to do the calculation by substituting the values by their units, so that how unit get cancelled we will understand in spite of mugging it. If you solve this, you will get answer 5.28 into 10 raised to minus 21 joule per meter second. Means minimum uncertainty in measurement of momentum is 5.28 into 10 raised to minus 21 joule per meter second. If this is the uncertainty in momentum, can we find uncertainty in the speed? Because what is momentum? P is equal to m into v. Then what will be the uncertainty in momentum? Delta P is equal to m into delta v. Delta v will be uncertainty in speed of the matter. Here we are talking about electron. So speed of the electron. For that we need to know the mass of the electron. What is mass of the electron? Right. 9.1 into 10 raised to minus 31 kg. Why I am expressing it in the kg? All are SI units. Therefore, I am expressing the mass of the electron in kg. So now delta V minimum is equal to delta P minimum divided by m, which is equal to 5.28 into 10 raised to minus 21 joule per meter second divided by 9.1 into 10 raised to minus 31 kg. If you solve, answer will be 5.8 into 10 raised to 9 meter per second. Pay attention towards answer. 5.8 into 10 raised to 9. What's the speed of light? Speed of light is 3 into 10 raised to 8 meter per second. Ever maximum speed one can attain. The delta V value what we found is larger than speed of the light. Means what are we saying? Minimum error in measurement of velocity delta V minimum is 5.8 into 10 raised to 9. It's a horrible joke. Our maximum speed is 3 into 10 raised to 8 and error in the measurement is more than the speed of the light. So it is not possible. Therefore I say electron is not possible to exist at center. Electron will not be at nucleus. Therefore electron is around the nucleus. I hope you got the point. Very interesting. Mathematically we are proving why electron is not at center. Means minimum uncertainty in measurement of velocity of electron is 20 times, almost 20 times more than possible maximum velocity. It is a very absurd, impossible. To make this concept clear, see, in our examination, a paper remains of 100 marks. So how many marks you can score? Maximum marks 100. And after completion of paper, if it is asked to you, how much will you score? And if you say Say you are thinking that 80 marks you will score. Then 80 marks plus or minus 2000. Impossible, no? Means your vicinity is, your error is 2000. In how many marks? 80 marks. So it is impossible. So 80 marks plus 2000 means you can score 2080. Or 80 marks minus 2000 means you can score minus 1920, which is impossible. Likewise, the conclusion we are getting for the position of the electron. Electron can never be at nucleus within that small region considering its mass. Therefore, we say electron does not exist at nucleus. I hope you are getting the point. Very interesting concept. Now, it is a time to apply our understanding of Heisenberg's uncertainty principle to explain the status or position of proton. Let us proceed. Let us do the calculation. As we did for the electron, we can find minimum uncertainty in measurement of momentum. Delta P minimum is equal to h upon 4 pi delta x maximum. What is the size of nucleus? We are considering maximum size 10 raised to minus 14 meter. Substitute the values. H is equal to 6.626 into 10 raised to minus 34 joule second divided by 4 into value of pi 3.14 into delta x maximum 10 raised to minus 14 meter. Answer is 5.28 into 10 raised to minus 21 joule per meter second. It is the uncertainty in momentum measurement. Minimum uncertainty in measurement of momentum. If it is so, then what will be the delta V value? Because delta P is equal to m into delta V. So minimum uncertainty in measurement of velocity delta V minimum is equal to delta P minimum divided by mass. What is the mass of proton? Yes, mass of proton is 1.67 into 10 raised to minus 27 kg. Therefore, delta V minimum is equal to 5.28 into 10 raised to minus 21 joule per meter second divided by 1.67 into 10 raised to minus 27 kg. After simplification, the answer will be 3.2 into 10 raised to 6 meter per second. Now this value is sizable. Maximum speed of the matter is 3 into 10 raised to 8 meter per second. And we are getting here uncertainty 3.2 into 10 raised to 6 meter per second. It is almost 100 times smaller than the maximum speed ever possible. Means now if you are going to score the marks 80, then you can say maximum marks are 100. 100 times smaller means 1. You can score 79 marks, means 1 mark less, or 81 marks, 1 mark more. So your marks will be within the range 79 to 81. It is appreciable. It is practicable. Therefore, practicability is existence of proton at nucleus. Therefore, proton do exist at center of the atom, at nucleus, in that small size. Even if we consider 10 raised to minus 15, then also will do. A small size is enough for the proton. Means see, even if there remains only one proton, for example, say one H1, we can't say proton is here at one particular position. Proton is in that particular vicinity, particular range, and that's our nucleus. It is not only one point where we can say protons exist at that point. Within a particular jurisdiction, within that particular size of the nucleus, proton or protons do exist. I hope this concept is clear to you. Now it is a time to think about neutron. Students, I want to give you this point as a homework. I give the information. Same way you have to follow. From Heisenberg uncertainty principle, you are getting delta P minimum. The delta P minimum is equal to h upon 4 pi delta x maximum. And we are talking about nucleus. Nucleus maximum delta x we are considering 10 raised to minus 14. So substitute the values, you will get delta p value. After delta p, when you need to find uncertainty in velocity of the materials, a minimum, delta v minimum is equal to, that's a delta p minimum divided by mass. What is the mass of the neutron? Mass of the neutron is same as like the mass of the proton, nearly same. It is 1.67 into 10 raised to minus 27 kg. So you need to find out the answer. What is delta V value for neutron? And write it in the comment box. So as a homework I am giving to you, you have to find answer for the question, where can neutron exist? For that, what is the minimum delta V value for neutron? That you have to answer. Second question, is this minimum value, uncertain value, is practicable? Is it less than the maximum speed ever possible? And third question, where will neutron exist? At nucleus or out? So all fundamental subatomic particles we have discussed, their position we have discussed. Hope you enjoyed the calculations. So there is a mathematical base for alignment, arrangement of the structure of the atom. Randomly we have not taken electrons are outside. Reasons are there for that. So let us understand these electrons more in detail.
I hope you got the point and understood the importance of Heisenberg's uncertainty principle. Fabulous work Heisenberg did. Now, in Bohr's model, we have studied energy levels, and for hydrogen and hydrogen-like species, it is applicable. So, what are energy levels? Means principal quantum number and their energies, in order to have the good understanding about the atom, good understanding about the energies. Let us find energies for hydrogen and hydrogen-like species for few principal quantum numbers, means for few orbit numbers as per Bohr's theory.
In next part.